In the age of rapid urbanization and industrial growth, balancing economic progress with environmental preservation is paramount. The Rawang Bypass, an 18-kilometer mega development project in Selangor, Malaysia, serves as a case study highlighting the intricate relationship between development and ecological impact. This report assessed the Rawang Bypass environmental implication, emphasized the need for an environmental impact assessment (EIA). It aimed to propose innovative solutions to mitigate adverse effects and examine relevant legislative framework for sustainable development. Approved under the 9 Malaysian Plan, the Rawang Bypass was constructed to alleviate traffic congestion in Rawang town. It includes a new road, a trumpet interchange, and adjustment to an existing further road. Notably, it features a 2.7-km elevated bridge cutting through a forest reserve. Utilizing our innovative movement surface system (MSS) construct method to minimize deforestation.
Assalamualaikum and hi, my name is Dato' Adawiyah binti Mustamam, AA4222. Today, we are exploring the significant environmental impact of the Rawang Bypass project during and after its construction. Firstly, environment impact during construction. The Rawang Bypass project's construction has profoundly affected the surrounding ecosystem, primarily through habitat destruction. Massive land clearance disrupted natural ecosystems, raising concerns about biodiversity loss. This disturbance goes beyond physical alteration and it breaks ecosystem connectivity, posing a threat to genetic diversity and species mobility. For the second point is soil erosion. Soil erosion is another critical issue during development. Substantial land clearing leaves soil exposed and susceptible to erosion, impacting downstream ecosystems, soil fertility and water quality. The use of construction machines and equipment further intensifies soil erosion, affecting nearby water bodies and contributing to sedimentation, which degrades water quality and disrupts aquatic ecosystems. The next point is water body pollution. Water body pollution during construction is a noticeable issue. Construction operations release toxins into adjacent water bodies, impacting aquatic ecosystems, water quality, and potentially endangering aquatic life. Beyond chemical pollutants, construction-related contamination may include biological contaminants, threatening the ecological integrity of water bodies and the communities relying on them. For the last point is air and noise pollution. Air and noise pollution are significant consequences of the Rawang Bypass project's development phase. Heavy equipment, excavation and transportation release particulate matter, hazardous gas, and noise affecting local residents' health and the environment. Next is environment impact after construction. After completion, the Rawang Bypass project continues to leave a lasting impact of the ecosystems, particularly in terms of habitat loss and fragmentation. The massive land clearance during construction resulted in fragmented ecosystems, making it challenging for flora and fauna to move and interact. Despite post-construction ecological restoration efforts, recovering these fragmented ecosystems poses challenges, like raising concerns about long-term impact on biodiversity and ecological services. For the next impact is incomplete ecological rehabilitation. Incomplete ecological rehabilitation further compounds environmental issues after construction. Despite attempts to restore disturbed ecosystems, success varies, indicating challenges in returning the landscape to its pre-construction state. The incomplete restoration of native plants and ecosystem raises concerns about the long-term sustainability of the environment. For the last impact is water body contamination and disruption. Water body contamination and disruption persist after completion. Sedimentation reduction and the restoration of pre-construction water flows patterns are not fully achieved, impacting the health of aquatic ecosystems and raising concerns about the long-term sustainability of water resources and the communities relying on them. In conclusion, the Rawang Bypass project has significant and lasting environmental effects during and after construction. Understanding these impacts is crucial for guiding future infrastructure development that balance growth with environmental preservation.
Hi, my name is Sofia BTCD, AA20226. Will explain about Environmental Impact Assessment, which is EIA. Next, in Malaysia, Environmental Impact Assessment, which is EIA, plays a vital role in shaping sustainable development by ensuring that proposed projects are thoroughly evaluated for their potential environmental impacts. Governed by the Environmental Quality Act 1974, Act 127, and the Environmental Impact Assessment Order 2015, the EIA process is a systematic approach aimed at identifying, predicting, mitigating potential environmental consequences associated with development initiative. The EIA process begins with project screening to determine whether a proposed project falls under the EIA order scope. Projects listed in the third schedule of the order are required to undergo a detailed EIA. Proponents of the project provide a comprehensive description, including the project objective, size, location, and the technology used. Baseline studies are conducted to establish the existing environmental conditions in and around the project area. This includes studies on air quality, water quality, biodiversity, socio-economic conditions, and other relevant factors. Potential environmental impacts, both positive and negative, are identified and assessed. This includes considering direct and indirect impact, short-term and long-term effects, and cumulative impact. The EIA process includes an examination of alternative project designs or locations that may have fewer environmental impacts. This helps in selecting the most environmentally friendly option. Proponents are required to propose mitigation measures to avoid, minimize, or rectify adverse impacts identification during the assessment. This measure aims to ensure that the project is carried out in an environmentally sustainable manner. Next, a comprehensive EIA report is prepared, incorporating all the above information. The report is submitted to the Department of Environment, which is DOE, for review. The DOE reviews the EIA report and may request additional information or clarification. Based on the finding, the DOE decides whether to approve the project, approve it with condition, or reject it. If approved, the project must adhere to the conditions set by the DOE. Continuous monitoring is conducted to ensure compliance. Next is the bypass project with an area of 9.59 acres located in the right-of-way, which is ROW, of Highway Bypass Phase 1, which is Bandar Rawang, require an environmental impact assessment, which is EIA. The reason why this project required an EIA was because the issue at the time was that the alignment will cross the Kancing Heritage Park, which has its own ecosystem of flora and fauna, including the 400 remaining Giam Kancing trees, which is Hobia subulata in the world, which are highly protected. Problems related to determining the routes through the Kancing Heritage Park also posed some problems or uncertainties, and there was no clear alternative design available at the time. In other words, construction activity should not enter the area without ensuring that the route determination issue has been resolved and approved. Approval of the preliminary EIA report is given up to challenge 3150, which allows for any possible changes in the route before crossing the boundaries of the Kancing Heritage Park only. Any work beyond challenge 4400 of the new route on the eastern bypass that passes through Taman Warisan Kancing will require the submission of an additional report for approval. However, after that, the additional EIA report for the proposed new elevated alignment in Taman Warisan for Rawang City Bypass project, to be referred to as Phase 2 Rawang City Bypass Highway, was submitted to the Selangor DOE and approved in March 2007. Next, the proposed project is to create a temporary rock crushing plant. Therefore, a new supplementary EIA was prepared following the excessive production of granite rock because of blasting operation in Phase 2, Rawang Town Bypass Highway, which was underway at the time, which may lead to air and noise pollution. This complies with the baseline study for the EIA, which also includes an air quality assessment. Because the blasting activity has been approved, by the Selangor Department of Minerals and Geoscience and is already underway, this EIA will only include the activities involved after the blasting activity, including the transport of blasted rock and also the construction and operation of the rock crushing plant. The next one is there are 4 points of impact identification and assessment phases. The first one is drainage and flooding. Surface runoff managed through silt traps before discharging into existing drainage system, so 2 proper silt traps to attenuate increased stormwater and runoff. The second one is water pollution. The dust suppression at crusher and screener may lead to high sediment level. To compliance with Environmental Quality Industrial Effluent Regulation 2009, 2 silt traps constructed and stormwater directed to them. And the third one is air pollution. The dust generated during crushing and screening activities and dry collection and wet dust suppression techniques employed. The air modeling indicates CO concentration within permissible limit. And the last one is noise pollution. Noise mainly from major equipment and increased traffic. Predicted noise levels assessed through modeling. Expected impact localized, monitoring during operational phase. That's all from me.
Today, I want to tell about the solution for the impact before and after construction. For the impact, erosion and sedimentation, we have erosion and sedimentation control plan. For the construction phase, we have erosion control and sediment control. As no work will be carried out, soil erosion is expected to be negligible. Temporary measures such as aggregate and crusher run can be used and placed over the exposed ground area and especially along the internal site access road. Buffer strip or corridors of vegetation should be retained to the separate disturbed land from the adjacent watercourse. A minimum width of buffer strip should be no less than 10 meters. For the sediment control, 2 silt traps will be constructed within the project site to trap surface runoff from the proposed site during construction activities. All surface runoff will be discharged to the existing drainage system via an underground culvert. The stabilized construction access is repaired at the access road leading up to the complete construction phase, Rawang Town Bypass Highway. For the operation phase, silt trap system is proposed for the developed area. The surface runoff is routed into the drainage network within the project site and ultimately flow into the silt trap. Solution for the water pollution in construction phase is storage and handling of scheduled waste should be carried out according to the Environment Quality Regulation 2005. All construction waste and debris to be collected and transported for final disposal at the designated municipal dump site. Temporary collections area are not be placed near waterways to prevent waste and debris from washing into the receiving waterway. In construction phase, 2 silt traps to be constructed at the lowest point of the project site where the surface runoff movement will be directed to the silt trap. Discharged wastewater from crushing plant will also be directed to the silt trap and then recycled back to the plant. Next, the solution for the air pollution in construction phase is employ good housekeeping to control fugitive dust effectively. Vehicle transporting construction material or debris out the project site should be properly covered with canvas or plastic sheet and cycle properly to minimize dust and particulate dispersion to the surrounding atmosphere. The on-site road network must be in a good servicing condition. The driving speed of the vehicle within the construction site should be limited to 30 km per hour to reduce soil lodgement and dispersion. Wetting of the site should be carried out as and when needed to prevent dust turbulence. Open burning of construction debris or filled vegetation should not be allowed under any circumstance. Heavy machineries and transportation vehicles should be maintained and checked regularly to ensure that they are in a good working condition in order to minimize smoke and soot emission into the atmosphere. Ensure that emission comply with the regulatory limit promulgated by the Road Transport Department (RTD) and Department of Environment (DOE). For the operational phase, water sprinkler and water bowser will be utilized on site on a more frequent basis. Enclosed conveyor system will be provided to reduce dust emission from the crushing activity. Project site will be lined with structure run to prevent dust turbulence and tracking of loads of material into the highway. Heavy machineries and transportation vehicles should be maintained and checked regularly to ensure they are in a good working condition. Next, solution for noise pollution in construction phase is driving speed of vehicle within the construction site should be limited to 30 km per hour. All construction equipment must be properly maintained so that they do not produce noise higher than the specified by the manufacturer. Crane or roll loader movement should be confined to daytime period which is from 7 AM to 7 PM. Hoarding should be set up around the site's boundary as a temporary noise barrier. For the operational phase, hoarding will be retained at the perimeter boundary of the project site as a temporary noise barrier during the operational phase. A crushing activity and vehicle movement should be confined to daytime period which is from 7 AM to 7 PM. All construction workers who are involved with extensive noise emission activity should be equipped with hearing protective device such as earmuff. In addition to this, warning sign should be installed at the high level noise area to alert worker of the noise danger. Noisy machinery equipment should be preferably be placed as far away from the southwest boundary of the site where the nearest residential area is located. Lastly, for a solution for the ecological aspect in construction phase is the removal of vegetation from the project site is predicted to the negligible as the project site is located within the ROW of construction phase Rawang Town Bypass Highway, which has previously been cleared for the road alignment. No mitigation measure necessary as the project site has neither any endemic species of flora nor endangered species of fauna. That's all from me. Thank you.
So we have two acts that related to the issues. The first one is Environmental Quality Act 1974 and the second one is Scheduled Waste Regulations 2005. So, for the Environmental Quality Act 1974, it is stated that every application to carry out any work, building, erection or alteration must be filed to the Director General and must be accompanied with the planned work, building, erection or alterations plans and specifications, as well as information of the control equipment. Besides that, details of the planned trade, industry or process, as well as descriptions of waste elements and their characteristics should be supplied together with any additional information that the Director General may. Not only that, it is also prohibited in Environmental Quality Act 1974 for any person to discharge environmentally hazardous substances, pollutants or waste including oil into the Malaysian waters in contravention of the acceptable condition. Next is Scheduled Waste Regulations 2005. It is stated that the solid waste generated during construction activities will be transported for disposal to a dedicated landfill at Bukit Beruntung, approved by Majlis Daerah Hulu Selangor. On the other hand, the scheduled waste must properly dispose of, processed on site, recovered on site of materials, or products from scheduled waste or sent and received at designated premise for processing, disposal or recovery of materials or products from scheduled waste. Last but not least, the scheduled waste must be disposed of in a suitable container for scheduled waste disposal, durable and which can prevent spillage or leakage of scheduled waste into the environment.
In conclusion, the Rawang Bypass project in Selangor highlights the need for a balanced approach to development, considering infrastructure and environmental conservation. An environmental impact assessment (EIA) was crucial due to concern about ecological disruption, habitat loss, pollution, and community impact. The solution section is vital, outlining measures like minimizing destruction, sustainable construction, fair compensation, and eco-friendly design. Adherence to relevant law on environment protection, land use, and community welfare is essential. Ultimately, prioritizing a sustainable approach that balances development is environmental preservation and community well-being is crucial for such projects. Okay, that's all from us. Thank you.